Hey everybody, welcome back to Geometry with Mrs. Gunn. Today we're talking about Chapter 11.1, the meaning of volume. Make sure you have a copy of the guided notes, or you can print them off of Ingrade, and let's get going here. The volume of a solid is the number of cubic units needed to fill up the interior completely. So if I had some container and I wanted to find the volume of it, I would be trying to figure out how many cubes of a given shape, of a given size, I could put into it. And so there are some postulates that go along with that. Postulate 11.1 says the volume postulate. Every solid has a volume given by a positive real number, meaning you can't have a negative number that's a volume. And you can't have an imaginary number that's a volume. It has to be a positive number, a real number. Postulate 11.2, congruent solids postulate. Congruent solids have the same volume. Obviously, if you have the same size box, two of them, they're going to have the same volume. Two of the same size sphere are going to have the same volume. Okay? And postulate 11.3, the volume of a cube postulate says the volume of a cube is the length of one edge cubed. The length of one edge cubed. So we write it E cubed. Instead of saying S for side, we used that for a two-dimensional polygon, like for a base. So on a cube, we're going to say these are all edges. So you've learned before that to find the volume of a box, it's length times width times height. But in geometry, we call them edges. Okay, and in a cube, they're edges. Okay. So if this were, the edge were 3 centimeters, then we could say the volume would be 3 cubed centimeters cubed, which would be 27 cubic centimeters. Volume is always cubic. We learned that area was always square because we were talking about how many squares it would take to cover a surface. Volume is always cubic units because we're looking to see how many cubes of a given size would fit into a given shape. All right. Postulate 11.4, the volume addition postulate. Now you may not have this picture in your notes. It's on page 462 in your book. You can refer to it there. You can try to copy it in if you want, if you don't have it. The volume addition postulate says if the interiors of two solids do not intersect, then the volume is the union of the sum of their volumes. So here's this funky shape right here. And you can see it looks like 3 prisms stuck together, 3 boxes stuck together. So we can calculate the volume of this whole shape by finding the volume of each of the 3 prisms, that one, and that one, and add them all together. So let's go ahead and do that in a minute. We're going to come back to it in a second. Okay? First, I want to tell you the next postulate. The next postulate says the volume of a rectangular prism is the product of its length, its width, and its height. So volume for it is going to be length times width times height. And notice I wrote a cursive L, that's not slant. Here, length. You could do length, width, height like this with capital letters, but then that might be confusing for lateral area. It's not lateral area, okay? We're just kind of running out of letters. So this is length times width times height. So let's find the volumes of these. The volume for this prism is length times width times height. So we've got 2 times 4 times 8 meters. And I'm going to write meters times meters times meters because I want you to see it's cubic meters. It's 2 meters times 4 meters times 8 meters. So 2 times 4 is 8 times 8 is 64. Meters times meters times meters is cubic meters. And you can write it like that. How about this one? Volume is length times width times height. Volume is going to be 5 feet times 7 feet times 9 feet. So it's cubic feet And 5 times 7 times 9 is 315. So 315 cubic feet for that one. For this one, volume is length times width times height. So 7 times 3 times 11. So that's going to be 231. Don't forget your units, centimeters times centimeters times centimeters, cubic centimeters. Okay, so now that we've got this theorem, let's go back. Let's figure out the volume of this weird shape. So I'm going to just break it apart because these interiors do not intersect. I could cut this apart into 3 separate prisms. So let's do that. Let's do the top one. The top one's going to be length times width times height. So 4 times 2 times 2, which is 16 cubic units. The bottom left is going to be 8 times 8 times, what is this distance? Back here. So we may have to decipher from some other areas of the diagram. I know this is 8. I know my height is 8, but what is this length here? Well, I can see right here is 2, and this is 6, which means that this part right here is also 6. So 2 plus 6 would be 8. So this is also 8. This is a cube. So 8 times 8 times 8 equals 512 cubic units. And then we can do bottom right. What are the measurements there? Well, let's see. We've got 10 by 6. I need to know the height here. Well, how can I figure out the height? Look elsewhere in your diagram. Look, there's 8 here, and we said this is a cube, so this is 8, which means this whole length is 8, but we know this top part is 3. So that means that this bottom part here has to be 5, and this bottom part is equal to the height of this particular prism. So this one is 10 across, 6, the length is 10, the width is 6, and the height is 5. So 10 by 6 by 5, that's 300 square units, cubic units, sorry. So let's add all of that together and we get what? 828 cubic units. So they're really pretty easy. The hardest thing about these is looking at the diagram to find any missing measurements that you have. If you look somewhere else in the diagram, there's going to be some way for you to come up with any missing numbers. Let's look at this example. You may not have this in your notes. You may have to copy it down. It's not going to be in your book. It's just an extra example in the teacher book. How could we find the volume of this? Well, we can break it apart. Think about breaking it into a a prism on the top, and maybe a prism across the bottom here. So we've got 1, 2, 3 prisms. Let's see if we can figure out the measurements of each one, of each of them. The top, let's see, what have we got? It's 6 long, it's 5 wide, and it's 3 high. So it's 6 by 5 by 3. Well, that's 90 cubic units. So that's that part. Now let's see about this middle one here, this long one. How long across is it here? Well, this distance is the same as this distance across here. And I know that this part across here is 14 because that's 14. And I know that this distance here is 6 because that is 6. So this length is 20. It's 20 long. How tall is it? Well, I know that this whole piece here is 8, but we said this was 3. So that means this bottom part of it here is 5, because if this part is 5 and this part is 3, that makes the whole thing 8. So I know it's 5 tall. Now how deep is it? Well, it's the same depth back this way, right here, as this is, and that was 5. So 20 times 5 times 5 is 500 square units. And then let's do the bottom. Let's figure out, well, we know it's 4. How deep is it here? Well, this depth is equal to this depth, is equal to this depth, and this depth, and this depth. Well, there's 5. So I know it's 5 deep. How high is this box? Well, this whole thing was 12, right here. But we know that this part was 5. So we know that the top part is 5, which means the bottom part has to be 7. So it's 4 by 5 by 7, which is 140. Okay? Not square units there, cubic units. So we can add all of that up, and it comes out to be 730 cubic units. So you're going to have to think about looking at the measurements on different parts of your diagram and calculating what these different lengths are when you cut these prisms apart. But it's not too hard. Alrighty. So I wanted to give you some clues to help you with some of the homework questions. Number 9, 10, 11, and 12 look a little tricky. So I wanted to kind of point you in the right direction. To find the volume of this cube, they tell us it's a cube. We know that its volume equals edge cubed, but I don't know what the edge is. So we're going to use, because this is a cube, all these angles are right angles. You're going to need to use the Pythagorean theorem. The diagonal is 10, and you've got the two edges that are the same length. So you can say that this edge squared plus this edge squared equals 10 squared. Okay, so that's how you're going to go on to find your edge and then find your volume. All right, number 10 has a similar thing going on, except our right triangle is in a different spot. Okay, see how we're going from the diagonal from this corner to the back bottom corner here? Well, your right triangle is going to be through here like this. So your right triangle is like that. This hypotenuse is 6, and then you've got this right here and this right here. So that's for the upright right angle. Okay, the one standing up here. But I'm going to use the base here because I need to find the length of the edge. This diagonal, I don't know how long it is, but I do know that my edges, I can say they are edge like that, okay? So I can say that the edge squared here plus the edge squared here equals my diagonal squared. And I can solve for the diagonal here. So that's 2 times the edge squared equals the diagonal squared. If I divide by 2, the edge squared let's not divide by 2. Let's back up. Don't divide by 2. Alright, so 2 times the edge squared is the diagonal squared. If I take the square root of both sides there, That gives me the square root of 2, and the square root of the edge squared is the edge equals the diagonal. Okay? So that diagonal is the edge times the square root of 2. But that diagonal right there is the bottom of this upright triangle. It's this diagonal right here. So I can say that that's the edge times the square root of 2. My upright here is edge. And now I can use this Pythagorean theorem to find what the edge is. So this edge squared plus this length equals 6 squared. You could go on from there and find the edge, and then you can find your volume. Okay? I don't want to give you the whole thing, but the whole thing is worked out in the long answers on InGrade. Number 11, similar idea. We're going to have to use the Pythagorean theorem. You can see there's a right triangle in here. Okay? And if you think about that right triangle, there's also a right triangle in the bottom here, in the base. I know that this right triangle right here, this front edge is 3, and I know that this hypotenuse right here is 5, which means I can use the Pythagorean theorem to find this length right here. Okay, and after I find that length, I can use my second triangle, which is the upright right triangle right here. And this diagonal is the bottom of this upright triangle, so that diagonal is 5. I know the hypotenuse is 8 right there, and I can use that triangle to find my height right there. Okay, so when I find those, then I'll have what I need, my length, my width, and my height to find the volume. Okay, number 12 has a similar idea. You have to think about this being, these are all right angles in this prism. So this is actually a right angle in there, and there's a right triangle that is this diagonal right here, which they're saying is 7, and this diagonal right here, which is the hypotenuse, and then there's this height right here that we're going to need to find in order to find the volume of the cube. Okay, so use your Pythagorean theorem there to find that. Then, after you've found that, we need to find this width right here. Okay, and so how are we going to do that? We're going to think about the base here. If you took the base and if you drew this diagonal right here, it's the same as this diagonal. So in the base, there's a second right triangle. That diagonal is the hypotenuse right here. And we know right here is 4. That's the bottom of that right triangle. And so we can find the width right there. Okay, so using the Pythagorean theorem twice, we can find the width and the height so that we can find the volume of the cube. So give it a try. There are a lot of weird square root numbers, but you've got awesome calculators, and so if you get stuck, refer to the long worked out solutions on InGrade. All right, I'll see you soon. Bye.